So if I look here at this Wikipedia page, threat model, and I scroll down through this information, I have actually a small example here, data flow diagram, online banking application. And if I open that picture and make it a little bigger, then we see that what we have here is in a way a conceptual or architectural diagram of how a certain application or set of applications shall work together or is intended to work together to get to really provide this online banking functionality. So what we see here that we have a couple of tiers. We have the external part here. We have DMZ, internal, web server / app server and so on. And then we have something called restricted network, where we have a mainframe. And of course, this kind of map is something that you work with when you are on the architectural stage or the planning stage of a solution. And when you are working with this, this is not at all implemented yet, or it could be a change plan for some system that is going to be implemented in the future, and you would like to see what security considerations do I need to take into account before I go ahead and start installing stuff. So what you can do then is that you can create a model of this. So if I check here, we have this securiCAD Enterprise product, which is quite similar to what securiCAD Vanguard is doing. We have a model, it's model-based, we have attack simulations and all of that. But this is for also for, let's say, manual modeling and also for importing different kinds of external or pre-collected data. So I can go to modeler here. I can open my model of this online banking application example. And here I see what I have. I have an attacker. I have the external zone. There are some ways to really connect from the external zone to DMZ and then to internal and then to restricted, because the different systems that are planned to be located in these zones, they of course need to make contact with each other. And then this is a subset of this model, and if I check other parts of the model, I can see that I, for instance, have hosts here. In this host, we see that we have a Windows 10 workstation. This is the end client or external customer's entry point. The first position that they reach, or the only position they are intended to reach, is this web server with the front end. And we have a data flow that is going to really travel from one position over this network boundary here to the next position. And then from this one, we have another piece of communication traversing the next boundary, which is the application calls. And so far, since this is only on the planning stage from a business point of view, then I don't have much information about how this application will connect to the application server. But I know that there will be a web server here that need to collect information from and give tasks to the application server. And then we have other things like credential location. Credential location is this set of different credentials that are needed in order to make, for instance, this web server connect to the application server. So that means that it might be possible that this web server know about the way or the necessary credentials to really authenticate to this application server in order to really do something or create a task in the application service here. So this is the structure, and if I am running, we can skip that. If I'm running a simulation on this, I can check. We have different models here. We have only one model here in this example, and then we have different rounds of simulations here. So this is the same type of simulations that Eric was showing. And then if we check this report here, we have something called a high value asset. I have only assigned one, which is financial service user access. That's actually this service over here that I have assigned as particularly interesting or important. Other services or systems on the way could also be interesting or important, of course. But then you can actually assign them as something you would like to highlight in the analysis as well. But picking a system like this is a good way to really get an indicator of the expected attacker difficulty. So if I go on down here, then we have something called critical path. And critical path is the same thing as you were seeing in the Eric's presentation. We have an entry point and so on, and we have the auto layout here as well. So we have attacker entry point is external. That's the starting point of the attacker. That's more or less a drive-by attack opportunist. We have something called unknown service here. And unknown service is a concept for really saying that, well, since we only have this architectural planned map, we haven't decided, or we cannot know the status of the different systems yet. So that means that we know what type of system there will be in order to support this business process, but we cannot really tell the exact versions and things like that. But for instance, here we see that the HTTPS traffic request here, well, that is going to be served by a web service. And when it comes to web services, we know that common problems or entry points from an attacker's perspective is to really find a web exploit. And the reason that these are branching up is that these different categories of security problems with a web application, they are expected to help the attacker equally much. And then we go on this track over to the endpoint, which is over here, financial service user access. Then, as Eric mentioned as well, this is the main track that the attacker is expected to succeed with first. But it's not guaranteed to be successful, because there could be obstacles on the way that make this track actually not an option for the attacker. So that means that the attacker would actually try other things. So if we look at additional tracks here, we recognize this part here with the web application. But when we get user access on this web server here, we see that instead of just discovering a way to connect to the internal zone here, which was the main track, that's why it's red, we have other options as well. So like making use of this application client user access. And this application client, that's the client in the application server here, which is necessary to connect to the next system. And then we see that it's reaching the endpoint, which is this financial service user access here. So looking at this map, you could say that this is a set of attack steps or operations that the attacker is expected to try and make use of, and from an attacker's perspective, hopefully be successful with. So if we could make some of these more tricky to achieve, then we could delay this attack, exposing the attacker for the risk of being discovered. or we could even block it. So instead of looking at that map manually, we get a list of suggested mitigations here. And here, for instance, it says patch service software. That's sort of a no-brainer, but it says that we should, if we would patch 3 different specified pieces of services here, then it's expected to have an impact on this attack track. But we can also take a look at all of them, and we see that we have a collection of other services here that are not expected to help the attacker that much. So that means that to really block the main track and the second main track and so on, it would be beneficial to really patch a couple of services and looking at this list of mitigations to really see that they are prioritized according to what the simulations have found to be the expected track. So in a way, if we think about the maturity-based approach, where you would look at all these different parts to see that, okay, I have a quite extensive checklist for all of them. I need to fix that and that and that and that, or make sure that different things are in place or are not present. Then I would say that this is a bit of turning the task around, because you will see different tasks that are expected to be more relevant to the attack path than others. So I can apply these and I can run a second simulation and so on. But if I do that, I get other simulations. So let's see, I have the patching these services here. I can take a look at that report to see that, okay, now the expected risk exposure is something else. Well, it's still not impossible, but it gives other results. And then I can evaluate really, is doing these mitigations, in this simple example, patching a couple of services, well-selected services, going to be worth the effort really. And the effort of patching something could be actually a pretty tricky task or quite trivial, depending on what system we're talking about and where they are located. We also see that the list of suggested mitigations, well, now this patching task is gone, and instead we see other topics here, like install host firewall. Okay, then that operation became more important. Then one way of using this type of analysis, I mean, we have been looking at a model based on this map only, is to, if you are implementing this and then you implement it and put it in a user acceptance test zone, or you put it in some other staging zone. You don't take it into production yet, but when you are starting to implement this, or you could implement parts of it, then you could actually run vulnerability scans or other security assessment tools to add that information into your initial architectural model. And that way, we will not be seeing things like unknown application, or there might be a web problem with this web application here, but instead you would get information about if those problems actually exist, or if they have been mitigated already. So that's a way to really look at or incorporate this in your architectural or implementation process, where you are looking at the planned environment, and then you check it against your implemented environment. So that's it regarding this area for me.
Thank you, Joar. We had a couple of questions for you as well. And the first question is from Alex. If this is a model and an analysis done during the design stage, how does it relate to the rest of the process, like the implementation phase?
Yes, that's sort of what I mentioned at the end here. We have this data flow diagram, which is actually mainly focusing on how this system of systems or this setup is going to really deliver the online banking application experience to the end user. And then we have now we have set up this in a architectural or conceptual way that we need these things to be in place in order to really deliver that service. But then when we are looking at the half implemented or completely implemented solution in a test zone or similar, then we can compare those models. We can compare the results of the architecture or the design stage situation with the actual running environment later on. And in some cases, you will see that the risk exposure is going to go up because there might be security shortcomings that have been introduced that were not intended or not expected. But in some other cases, you might see that it's getting a lot safer than the non-enriched environment, because you will actually see that some systems might be more clean than the average.
Okay, great, thank you. Then we have a two-part question here. I'm trying to combine, we'll try to combine a couple of different questions into one here, but it's from Glenn and Amar, where the question is, if it's only used for architectural modeling, and what about my existing environment? And the question goes on to ask, how does it work at the process level for, say, SCADA environments?
Yeah, the thing is that it's slightly relating to the possibility to use different levels of details within a model. So suppose that I have defined a model for this part or this environment. Then I can take or I can create a model of my existing environment. And the existing environment model, that one is often a lot larger. And that can be created by using different types of input data like firewall configurations or network scans, not necessarily vulnerability scans, but that gives another level of detail to the material. So what I then do is that suppose that I have in this internal zone here or in the restricted network here, then I have other systems that are not really related to this, this application or this solution. But I can then connect other assets to these different zones automatically to really see how is this new planned solution or change going to affect the original model. That is also something that in that case you will have a model where you have a lot more details about your existing environment than about these additional sub-model here. Which means that you would see how that is going to affect your existing environment. And that's a kind of usual use case, because quite quickly you will see that you cannot have the same level of detail about all parts of your network. In the AWS example, of course, when Vanguard is fetching all the data programmatically from the AWS environment, and that's a slick use case. But when you are looking at the other environments, it might be that you have external communication with some other company, or some you need to, in the banking example, you need to deliver reports regularly to some authority. Then you know that you have communication with that other network, but you will never be able to know any other further details about that network. So that is going to be really a mix of existing environment and planned environment. And then when it comes to SCADA equipment, that is also, let's say, a similar thing, because if in this restricted zone you have a SCADA control system, you have engineering workstation, historian, etc., and a bunch of network zones forming that SCADA solution. And then in the further down in the architecture, you might have, or you will have, things like substations and so on, and RTUs that are more limited in their capabilities than traditional servers. In many cases, even though we have seen, lately we have seen RTUs that are actually based on Raspbian. Which means that they are fully fledged operating systems that you can use as any web server. But that's a side note. What you would do is that you can actually assign more industry-specific areas of your environment as being high-value assets. And that way you can really highlight how difficult it is expected to be for an attacker to reach a certain position in your architecture. And that is in many cases enough for really analyzing your risk exposure and finding the security problems on the way to that precious zone. And then we have the possibility to really define very industry-specific environments like onboard vehicle systems and, of course, SCADA environments and so on. But I believe we say that for another webinar.
Right, and also to just to add to what you said, that for enterprise environments, foreseeti also offers full APIs, so you can do imports continuously as well. Okay, I think we need to wrap this up, but just one final question. This is a little bit of a longer question, so we're gonna have to try to keep the answer a little bit short, but I'm gonna ask it anyway. Mina asks, what I see here is that you've modeled the application or solution like ordinary systems with services and clients and communication. But what if this solution is based on microservices instead, like containerized environments?
Yes, I mean, the models or the modeling objects we have been using here, they are, well, they could look like they are ordinary IT systems only. But in many cases, we can represent microservices and things like that as these services. And actually, this morning, I was looking at some article here, actually. So if yeah, this one is an attacker looks at Docker. And this is a black hat paper. And I would just like to show here. Yeah, with monolithic applications, this is really fun actually. With monolithic applications, specialist knowledge of the target application's programming language or its application binary interface is needed, etc. But it says that applications made up of multiple independent containers, and the conclusion here is that if you have microservices and so on, you give the attacker the opportunity to use standard tooling or start working with network attack enumeration and things like that to really get a head start instead of having to understand different particular or specific applications.